Alrighty, I think I blipped around between chapter 6 and chapter 7, just to make things confusing. We're in chapter 6 again, which is all about functions. Now, I've been kind of making y'all write functions from the very first day. Function is a named block of code. You give it a name, and then inside the parentheses you list the parameters, if any. The parameters are variables that accept the values that are passed to it when it is invoked. Those values are called arguments. Now this slide is going to show you something that I'm never going to ask you about on a quiz or an exam, I don't think. But the parameter can be called a formal parameter or a formal argument, and an argument can be called an actual parameter or an actual argument. Okay, well, when you go on and you take computer science classes at a four-year university, learn that again. I'm kind of kidding, but we're just going to settle on the definition that a parameter is the thing that's declared when you create the function, and the argument is what you pass to it when you call it. For each function argument, the prototype has to include the data of the variable being passed to it. If it's a prototype, you don't have to give it a name. You just list what it takes. But I think that the name is useful information. Now, in something like even or odd, you can probably guess what kind of data you're passing to it. But you know, if it's got several different variables and you don't know that one of them is supposed to be the temperature in Celsius and the other is supposed to be, you know, the pressure in atmospheres or whatever, that's useful information. Right, so if you have a function, you know, called calculate volume, and all I do is in my prototype, I tell you that it takes 3 doubles, right? And it's going to return a double. Okay, that's my prototype. And now I tell you to use this. Well, I give you a DLL. It's a library. It's got that function in it. And I give you the header, and you're supposed to write something. Okay, now when you're ready to calculate volume, you have no idea what these variables are supposed to mean. Hopefully I give you some documentation and you flip through the file or whatever, you can figure it out. But if it said this, you know, double, you know, pressure, atmospheres, and, you know, volume in liters, and then it had mass in grams, right, something like that. You know, if you saw that information, you'd know a ton more about how you're going to use that. So I say when you declare your prototypes, there's absolutely no reason to leave off the names, even though the books show you doing that. You can. There's no reason to. So I'll just say, when you declare a prototype, you can leave off the parameter names. But in Prof's opinion, that is useful information. And you should leave the variable names in. Why take them out? And I'll go back to my example of just passing in 3 doubles like this, which is easier to know how you're going to use. Oh, by the way, yeah, I want to play with that awesome for loop that I posted about. If D2L will load. All right, this is really cool. It's the kind of thing that would really frustrate me as a programmer, and it's really fun as well. And what I mean as a programmer, if I was looking at your code and trying to make a fix to it, and I saw that, it would confuse me if I had to make any changes to it. Now in this particular case, it is comprehensible, but you have to kind of take it apart in order to understand what it's doing. Now I've told you before that you can leave off every individual part of a for loop. So we could say that that happens first. I'm going to go ahead and leave this statement in there. But I'm going to take all of this stuff off. This is all the update stuff. And I'm going to move it in braces. Right? Now it starts to make more sense of what it's doing, right? We can figure out what it's doing when we break it up like that. And we can even see something that confused me at first, why we had to have minus minus total plus equals k. The reason we had to do that is because we are incrementing k before we add it to the total. So if we wanted to, we could rewrite it a little bit differently so that we wouldn't have had to do that. Right? All we had to do is do the increment to k afterwards, right? Like that. And so then when we wrote our code, yeah, I could use k plus equals 1 as well. It doesn't matter. Then if I move the increment until after it, I could do that like that. Now whether it makes that even harder to read or easier, I don't know. But what this says is add k to total. Oh, and we can get rid of minus minus now. And when the expression is done, then increment k. Hope that makes sense. Anyways, that's a pretty awesome loop. I dug that a lot looking at it, trying to figure out what it did. And you saw how I figured out what it did. I just hacked it apart like that. Moved the initialization above it. You know, effectively I turned it into a while loop at that point. You know, while that, keep doing that. So here's the prototype. Here's how you call it, or excuse me, that's the header for it. Since there's no semicolon at the end, that's implying that there's a body to it as well. They're not showing the body, but it's there, so that's the header. And then when we invoke it, we call it, we have to give it an argument. That argument fills that parameter. And then that parameter exists for the lifetime of the function, and it's used inside it to calculate whether it's even or odd. So the value of the argument is copied into the parameter when the function is called. The parameter scope is the function which uses it. So even though they didn't write it, I'm going to write this. I'm going to write a function for that. Right, so what's it going to do? You know, int x is equal to num modulus 2. If x is greater than 0, that means it's odd. So we're going to return false. Otherwise, we're going to return true. And we could have boiled this down to a single line of code rather than do that. But okay, so this variable here, and then when we called it down in main, right? Like that, or int main, either one works. This variable here, this prototype, exists from here to here. If we write another function down here, then it doesn't know what num is, right? That won't work, right? Because that variable's lifetime is between here and here. Even though it's not declared between those braces, we can treat it as though it was. We can treat it, the parameters are effectively declared inside the first brace. So the function can have multiple parameters. You can give default types to your parameters if you want, default values to your parameters if you want. There must be a data type listed in the prototype for every parameter. So if I write a function that takes 2 parameters, void zap, I can't do this, although I have typed it before, even probably in front of y'all. That's not valid code. Honestly, I don't know why they don't allow it, but you have to do that. You have to give each variable in the parameter list a type. Arguments will be promoted or demoted as necessary to match parameters. Now, in some languages, demotion is not allowed. Java will refuse to demote data because you can have data loss, right? You have a long and it's trying to be stored into an int. Well, the long is too big to fit into an int. The long is too big to fit into an int. Data could be lost during that transfer, so Java would flag that as an error. C++ will give you a warning about it, but it'll go ahead and compile. So remember that promoting means taking a lesser data type, a smaller data type, and storing it in a larger one. That's always safe, right? If you have this function here, And then when you call it, pass in a double, 3.141, you know, like that, or a floating point, or a long. It'll go ahead and convert this float to an int. It is an int inside here. If we do anything with it, that's called demotion. It took a large data type and put it in a small one. Now what if this was a double? And this was an int. That's cool. That's promotion. It's taking a smaller data type, putting in a larger one. There's no possible data loss, right? Because a double can hold a huge value. A 300 is obviously, any int is obviously going to fit inside a double just hunky-dory, right? So just be aware that this language does let you create expressions which do data demotion, and it's up to you to figure out if that's okay or not. Just be aware of it, that these data types should be of what you're expecting to pass to it. And if you're not passing that type to it, you ought to do the conversion yourself before you do that, just to prove to yourself, yeah, I know that it's going to convert it to an int. And that way, when somebody else is looking at your code later, trying to figure out what it does, and they look at this function call, oh, well, I guess that function returns and accepts an int as an argument. And so, well, I'm glad to know that. That's useful information. Whoops, wrong. Wrong. Right. So the number of arguments in the call must match the prototype in the definition, unless you have default parameters. The first argument initializes the first parameter. The second argument initializes the second parameter, and so on. And that's almost, obvious, right? But that one's going to fill in X, and that one's going to fill in Y. So here's our function call. Show sum, value 1, value 2, value 3. Fill in num1, num2, num3. Passing data by value. That's the default passing mechanism. And I've lectured for 30 minutes to the Java folks that Java is a pass by value language. That's all that it does. C++ gives you other alternatives. You can pass by pointer, and you can pass by reference. So we're going to wind up talking about all three of those. But by default, what happens is the value is copied into the parameter. Here, the value, well, it's called value, right? But the contents of value 1 are stuffed into that variable, like passing a photocopy to it. And the contents, the value, is photocopied and stuffed into that variable. And the value, the contents of that is stuffed into that one. That means that if these variables change, it does not affect these original values. So if I do this, go back to my notes, and I say x is equal to 100, and then down here when I'm calling it, I said z equal to 2, and then I pass z into my code here, and then I see out z, you might think that it changed it to 100, right? It changes it to 100 there. So surely z got changed. No. A copy of the data was passed into this variable, and so now x equals 2. It doesn't equal z. It's not the same thing as z. It just contains the value. I passed a photocopy of it in there. And if it feels like scratching, wadding up the photocopy and putting new data on it, great. I still have my original variable. So when I printed this out, it's going to print a 2, not 300. Howsoever, I can write a function that will actually let me change the contents of it. That's called pass by reference. I'm going to write one that does allow you to do that. You define it with an ampersand. I'm going to call this one zap2 because it passes by reference. And so now it sets x equal to 100. And then down in main, if we do the same stuff, z is equal to 2. And then I call zap2 and I pass z in. And then I see out z. Well, it didn't pass in a copy. It didn't pass in 2. Instead, it passed in a reference to z. At this point, x and z are the same variables. They're pointing to the same area of memory. They occupy the same memory address. And so when we set x equal to 100, we're also changing z. So that changes that this will print out 100, not 2, because Z was passed in as a reference. So this is pass by value, sometimes called pass by copy. A copy of the argument's value is passed into the parameter variable. And then down here, this is passed by reference. The address of the variable is passed in so that the parameter and the original argument are the same place in memory. And is that a good thing? Well, sometimes. If you want to write a function that can change the parameters, sure, why not? Let's go ahead and load up Visual Studio and we'll play with that. We're going to write a function that takes 3 parameters and it doubles them all, which you couldn't do in a pure pass by value, pass by copy language. Python and Java specifically are pass by copy, pass by value. What lecture we be on? Elemento P. All right. Lecture P.
Wouldn't it easier just to do it by the date?
I used to do it by date. And then I found that it was easier if I did it by letters, especially if I then reuse that material in a later class for an online version of it. Now, I don't teach C++ online, so we could still go by date, but some classes I do, so I adapted that habit for all of mine. Very good question. I don't know if that answer is convincing to you.
It is convincing to me.
All righty. All right, good old boilerplate. Alrighty. So I'm going to write a function called double that's going to take 3 parameters, x, y, and y, and it doubles each one of those. Oh, double is a really stupid times 2, right? Because double is a keyword. I can't name a function the same thing. So x equals x times 2. Y equals y times 2. So now let's create some variables. A is equal to 10, B is equal to 20. This is down inside main. We're going to call times 2, and then we're going to print those out. Times 2, A comma B. Now let's seed them out. C out A, followed by a space, followed by a B, followed by E and DL.
Shouldn't that be an error? X equals x times 2? How does that make sense?
You can make it an error, but no, it's not an error. What this does is it evaluates this expression, and all of that stuff is done before it notices the equal sign and copies it over. So that's the same thing as saying x times equals 2. It's the exact same thing. I've just been doing x times equal and x plus equals and x plus plus so much that this actually looks weird. Okay, but when I run it, it's going to print 10 and 20. It's not like x is going to be doubled and y is going to be doubled so that a was doubled and b is 20 and it prints 20, 40. That's not going to happen. It prints out 10 and 20. That's because it passed in copies of that data. the values 10 and 20 were passed in. Well, aren't I causing a lot of problems? Anyways, so it passed in 10, he got a copy of that data. Passed in 20, he got a copy of that data. And then he could mess with them all he wants. And what if you want to prove that these things aren't going to change? You could declare them as const parameters. It's no longer going to compile though, because here I'm trying to change x, but I said no, that was a constant parameter. You're not allowed to change it. I don't see a real strong reason for doing that. You could declare all your parameters const if you wanted to, all the non-reference, non-pointer ones. I don't see a reason to do that. Okay. But now we're going to write one called times 3, and it's going to accept reference parameters. It's going to accept references. The parameters are going to be references to the arguments. So void times 3, int ampersand x, and int ampersand y. So now when I do x equals x times 2, and y equals y times 2, or y times equals 2, again, they mean the same thing. If I call times 3, it actually will change those values. The ampersand means, oh, that's a reference to the original memory space. So times 3, a comma b, and let's print them out again. So I'm just going to copy and paste that cout statement.
Your times 3 does not times 3.
Oh, you're right. It multiplied everything by 2. But we did see that it affected the original variables. But why don't we actually do what I said rather than what I typed? So it was able to change the values. Now there are some side effects to that. What if I declare these as const? I'm going to add the word const to where I declare a and b. Does that break times 2? No, not at all. Because when we call times 2, these values, 10 and 20, get called in there. But the data is safe. You know, we have the original. Does it break this, though? Yes, it does. Because declaring these as references strongly implies that this function is capable of changing those things. And we're not supposed to be able to change them. Now, can you get it to compile? Could you make that const and that const? Well, now that's going to break this again. Right? Because we're not supposed to be changing those. So, and if you're going to pass it in as a constant, then why'd you pass it in as a reference? So anyways, I'm going to get rid of those. Okay, I'm going to take the word const out because that did break my call to times 3. It does imply something else though. If I do times 3 and I pass in 2 numbers like 100 and 200, this won't compile either. Why won't that compile? These are ints, aren't they? Yeah, but what does it mean? It's passing. Is this somehow going to magically change the value of 100 to 300, right? And then every other time we type in 100, it's going to mean that it's 300? Or every time we type in 200, it's magically actually going to be 600? No, no. If you use references, the data that you pass in has to be a variable and neither a constant nor a literal, which is an unnamed constant. So that's wrong. Can't do that. If you have a very large data type, a structure that contains a lot of members, it's faster to pass it in by reference because it's not passing in all that data. Say you have a structure that contains 10 million pieces of information, 10 million bits. It's a 10 megabit picture stored all in one structure. Well, when you call that function, if that data was all being passed in by value, it would sit there and it would pass in all 10 million bits. 1.4 million bytes, whatever. But if it's passed in by reference, what's it doing? It's sending an address. It's sending a single chunk, right? I don't know if addresses are 4 bytes or 8 bytes or whatever, but anyways, it sends in a very small amount of information. So this can be faster if you're passing around large pieces of data. While we're talking about structures, I want to give a demonstration of one. Let's create a structure, struct, and I'm going to call it patient. And every patient has a name and a height in centimeters and a weight in kilograms. So now I'm going to create a patient. Patient P1, P1's dot name equals Joe. P1's dot height in centimeters is equal to 170 centimeters. And P1's dot weight in kilograms is equal to 100 kilograms. Now I'm going to create a second patient. It's going to have different information. Sally's going to be shorter, a little lighter. So I'm going to create patient P2 and put that information in. Patient P2. P2's not name is Sally. I'm going to do some stuff just to get more of this to fit on one screen. P2's dot height in centimeter is equal to 150. P2's dot weight in kilograms is equal to 70. So we have clusters of information. This one variable name represents 3 pieces of information. Represents a name and a height in a kilogram. And this other variable contains 3 different chunks of information, right? It has a different name and a different height and a different weight. So let's write a function that uses that structure. We can pass in a patient and it'll print some information out about that person. So void print patient. And what does it accept? Patient P. I don't really like calling it P because that in my mind means pointer, so I'm going to call it pet. Patient pet.
Giving me an error on the second patient P2. I don't know why.
All right, let me come look. Matter of fact, let me delete that temporarily, get all this up on the screen. All right, so I want to create a method called print, not a method, a function, called print or print patient. So void print patient, it takes a patient as a parameter. I'm going to call it, I'm going to leave it P, whatever. Okay, and so let's see out the person's name. Name equals, end quote, arrow, arrow, name, followed by a comma and a space, except that should have been P dot name. And then see out, arrow, arrow, height equals, end quote, arrow, arrow, P dot height centimeters. Arrow, arrow, quote, comma, space, end quote, semicolon. And I'll slow down in a minute. And then I'm going to do weight. See out, arrow, arrow, quote, weight equals, end quote, arrow, arrow, P dot weight, kg. Now I'm not going to put a dot or anything because this is the end of the line, so I'm just going to do ENDL there.
I feel my fingers with the cold. Jesus.
Yeah, yeah. I'm going to scroll down a bit, and after I create my two patients, I'm going to print them out. Print patient P1, and then on the next line it's going to say print patient P2.
I thought you wanted to call it Pat. What happened?
I changed it back to P. If you want to call it Pat, make it pat.name and pat.height and pat.weight. Print patient P2. So a parameter doesn't just have to be one value. It could be a cluster of values, right? Stored as a structure. So structure is just a package containing several variables rather than just one. There's more than one. There's another way you could pass data around where you're passing in more than one value. An array, right? You have an array of 7 different values, right? And so you pass that array in and it can play with all 7 values. So I'm pretty sure that all of this data, well, let's find out how big that one of these is. I'm going to use size of, just to print out a size of a patient. What do I mean? The number of bytes that it occupies, right? This is just for my curiosity only. C out, quote, or error quote, size of, parentheses, P1, in parentheses, is, end quote, error, size of P1, in parentheses, error, India. That's just for my funsies. I want to find out how many bytes one of these patient structures takes. .48. So we have 48 bytes worth of data stored in this structure. When we call this print function, it's going to pass in 48 bytes of data. If we declare this as a reference, like that, it's going to pass it in more quickly. I think memory addresses are 8 bytes. Could be wrong about that. Would take less data copying to do like that. Now, if I pass it in by reference, there's always a risk that any changes to it would affect the original data. And so I could declare it as a const reference. That means do it the most efficient way possible, but don't let it change it. It won't be able to change any of the pieces of data. Now that is a good reason for using const and a reference. You're passing it in, it's being passed in the most efficient way possible, it's being passed in as an address, but it won't be able to change it. Now we're kind of getting to the point where this starts looking a little bit weird. What I really want you to know at this point is how to write a function like this, right, that accepts parameters and returns a value. Do I care yet if you know how to write a structure or write a function that accepts, a structure type and does something with it? No, but I want you to tuck that away in your head, and then the next time you see it, it'll make more sense. And then when we start talking about classes, what is a class? A class is a structure that also has functions inside it. We'll get there. For now, I'm going to go ahead and remove that const, and I'm going to remove the reference indicator, just so that it looks as simple as possible. Now I've done something right. What? Do I need to rebuild it? Oh, okay, it's one of those errors that magically goes away as soon as I save the document. All right, I better pause and make sure it's working for y'all. All right, so passing data by value. The argument is copied into it. Changes to the parameter do not affect the value. Using functions in menu-driven programs. Yeah, it's kind of lame. Functions can be used to implement user choices from a menu, or to implement general-purpose tasks. Higher level functions can call general purpose functions, minimizing the total number of functions and speeding program development time. I don't see what this has to do with menus, honestly. Yeah, sure. You could write a menu that looked like this, right? C out, press 1 for Spanish, 2 for English, 3, 4, whatever. Japanese. And then, you get your input in. And then if choice is equal to 1, you call the Spanish function. You go and play them a greeting in Spanish. Else if choice you get the idea. Else if the choice is equal to 2, then call, the English function. And so on. Right. What do you use functions for? You try to break up your code into units, smaller units, rather than write a main that has 100 lines of code, split it into a couple of functions. The functions are easier to debug, hopefully. You can prove that this function works. If you write small functions, you can prove that those work, and then you can reuse them over and over and over. Now, I know I already showed y'all how to create a header file full of prototypes and to stick all your functions in a separate CPP file. And then when you need that stuff, you can just bring that CPP file into a new project. Bring that in, bring in a new header file, and you're ready to start using your functions. The return statement. It ends the execution of the function, but that's not the only thing it does. It passes data back if you specify any data to be passed back. So, we're going to write a function called triple. It's going to take an int and return an int. Int triple, which takes x and returns 3 times x. The return statement ends the function. So even if we had some code here, right, cout, whatever, that's never going to be run. Java wouldn't even let it compile. I'm hoping that this will at least flag it as a warning. C# wouldn't let it compile. Those are stricter languages. Nope. Didn't even get a warning about it? Well, whatever. So that means that you can have more than one exit from a function. Like if a function succeeds, you could return one thing. And if a function fails, you could return something else. Like we might write a div function that divides 2 numbers, returns a result as a reference variable, and if it succeeds, it returns a true. And if it fails, it returns a false. So I'm going to write double try divide. It takes 2 doubles, double x, double y, and it returns, or doesn't return, through a reference it will pass back a result. So double ampersand result. Well, since it's going to pass the result back that way, I can make this return a bool. True if it succeeds, false if it fails. False if it tries to divide by 0. So I'm going to handle that case first. If y equals 0, then return false. It's a problem. Otherwise, else return x divided by y. So now in our calling code, we can call try divide. Oh wait, that's not right. Why is that wrong? What is try divide supposed to return? It's declared as what type?
True or false?
Yeah, so why in the world is it returning a number? It's supposed to return a true, or a false, and then the result is supposed to be passed back in that variable. So we're going to have to make this a little bit clearer. I'm going to restructure it quite a bit. I'm going to take the else out completely because it's implied, right? Because if you don't return, then you're going to keep going. And so result equals x divided by y, and then return true. So the division actually worked. That is a good use of the reference type. It gives us a way to change more than one piece of data. Our times 2 and our times 3 also did that in a way. They changed more than one piece of data, right? They effectively had more than one return value. These languages only let you return one piece of data. There are other languages that'll let you pass back more than one piece of data. You can have to, return x comma y, and both of those things will go back to the calling code. But not C, C++, C#, and Java. So down in main, if we wanted to, we could call that function. I guess I'm not going to even bother, but I'm going to give an example. Bool OK is equal to, well, we better declare a thing that will hold the result, right? So double z. How about double x is equal to 1, y is equal to 2, and then z. I'm not giving z a value because it's going to be erased by whatever's in here. And then so I call bool OK is equal to try divide. I should have put mage, I'll do this in main. Anyways, x comma y comma z. And then if OK, then do something. Otherwise, print an error message. Like that. So you have a couple of reasons to pass things about by reference. One is that it's faster than doing a copy of the data if the data type is larger than an int or a long. If it's longer than 8 bytes, then it's faster to copy it with a reference. The other reason is so that the function can pass back more than one value. So it can return one thing and then modify one of the values of the parameters as well. So, if a function is declared as void, you don't have to have a return statement. That's why our print patient function didn't have a return. It was declared as void. You can stick one in there, doesn't break it. It's just implied. It's useless frippery, right? Because you know it's going to return anyways when it hits that. And it's not going to return any value because it was declared as void. Returning a value from a function. Fundamentals call that a fruitful function. Returns a piece of data. So, int sum num1, num2 takes those two values and returns the result. Now this is a bit bizarre. What do you find bizarre about this? Somebody tell me what I'm dinging.
Returning a double even though it calls for
Right. Why in the world is a result declared as a double and then, if that's the case, I think I would declare this as a double. Maybe there's a very clever reason for doing that. The only reason I can think for doing that is if both of these numbers are too large, so that they add up to be larger than the maximum value of an int. Well, yeah, great, it would be stored in a double, but when you did that and it got converted to an int on the way out, it would still be too large. That wouldn't fix it.
But would it work though if you returned it a double even though?
In this language, yes. In Java, no. If I copy and paste this into C++, it'll work.
So
It's called implicit conversion, but it demotes the data type. This is a double but it gets demoded into an int. It gets squished to fit into an int.
So
And
like, what if you're making a calculation, but you knew at the very end you'd round it up to the nearest int. That's why.
sure, you could do that. There could be valid reasons for doing an intermediate calculation with a more complex type, and then, but if I was going to do that, I would probably do something like this to just prove that I knew what I was doing, so that somebody looking at the code would understand. You know, especially if this was like a page full of code. By the time you get down to the bottom of the code, you may not remember that it was supposed to return an int. So if you saw that,
So when you normally want to round up in it like a double, can you just directly add the what's it called, the int part, and make it an integer?
right?
Okay.
In this language, it'll do it automatically, though. You don't have to cast if you're doing a data promotion, but you
So-
do have to cast. No, in this language, you don't have to cast to do a demotion. In Java, you do.
But so like for example in Java, if you didn't have the cast, could you just make a function that rounds up a number for you and you would use that?
Sure,
Would it be necessary or is there a shorter way to do it
I would cast it.
in Java too?
Yeah,
Okay.
in Java, casts are necessary in order to get a larger data type to be treated as though were a smaller one. C++ is happy to go ahead and do that for you, and it doesn't care that you lost data. Java's just warning you, oh, you're going to lose data. I'm going to make you cast it to prove that you know what you're doing. Anyways, that was kind of odd. Here's the same one, but it returns an int. They declare this as type int, but they declared their answer as double, and then they returned that also or double. But here, they didn't do any monkey business. They didn't store an intermediate value. So their two examples don't match. But it works. You can either declare the variable, perform your calculation, and then return it, or you could just return num1 plus num2. My only argument for doing it this way is if you store it in a variable, then when you run it through a debugger, you can inspect that variable before it's returned. Or you can add a print statement to print out that variable before it returns. If it's returning a void, then you can't store its result. Like I had this this times 3 function. If I go down here to times 3, wherever I used it, and I try to store that in a result, int x is equal to times 3, like that, won't work. Because it's not returning anything. It's declared of type void. So void cannot be used to, this is what it says in that tiny print, void cannot be used to initialize an entity of type int. In other words, it's going to return a void. There's nothing to store. That's all void means, is that there's nothing. So we can't create a variable to hold its result. If I cared, I would go and I would change its return type.
Are you getting the triple function working on this one? I don't think you called it on here, but I can't.
I never called it. Let me move it down in front of main and then call it.
Because I'm trying to get it and it's just not even returning anything for me.
C out, arrow, arrow, triple of 10.
Oh, that makes sense. I should print it out.
Yeah, you gotta display it or else you don't know what it's doing.
Yeah, okay.
Yeah. So yes, you can return a Boolean value just as well as any other, in which case it's going to return a true or false. I had my try divide return a Boolean value so we could check to see whether it succeeded or not, the failure condition being defined as a divide by 0. Locals and global variables. I'm pretty sure I've talked about global variables. Somebody tell me, have I talked about global variables? Yes. A global variable is one that's defined outside of main or any other function. So it can be accessed anywhere in the code. A local one is one that's defined inside a function. Global variables are considered poor taste. That's a silly way of putting it. They make the code more difficult to follow and more difficult to debug. But I've used them. They're useful.
Right, I thought we already did this.
Pardon?
I thought we already did global variable.
We have, so I'm not
Oh,
going to do a big
sorry.
lecture on it. The local variable's lifetime is the braces in which it's defined. Initializing local and global variables. You don't have to initialize global variables. If you don't initialize them, they get the value of 0. You do have to initialize local variables. If you don't initialize the local variables, they equal some random value, whatever was in memory at the time. To me, I'm going to go ahead and initialize the global variable too, right? Even if I just set it to 0. Static local variables. Okay, this is new stuff. I don't think I've talked about static. I could be wrong. You Java guys don't say you've talked about static because it means something different in this case. Have I talked about static? Nope, okay. Static means that the value does not lose its state between calls to that function. What do I mean by that? I'm going to write a function called, I don't know what I'm going to call it, hello. And I'm going to create a variable called I. I'm going to add 1 to I. And then I'm going to print that value out. I don't know why it's called hello, if that's all that it's doing. Right. There we go. If I call that multiple times, it's going to print out 1 each time. Call hello, call it 3 times. It's going to print out 1 3 times in a row. Why? Because the variable disappears as soon as that closing brace is hit. So the next time it comes in, it's reset equal to 0. Adds 1 to it, prints that out. 1 again. Howsoever, if you declare this as static, what that means is preserve its value. Its value is actually stored outside of that function. Honestly, it's stored in a different place in memory. But you can think of it as being marked, do not erase that data when you leave the function. So it gets increased to 1, but the next time we call it, it skips that statement, and it still has a value of 1, so it's going to get increased to 2 and print it out. And then the third time we call it, it comes back up here. Well, it's already been declared, so it skips that. It adds 1 to it, it's equal to 3. So it printed out 1, 2, 3. Whereas, if it was not defined as static, it would just print 1, 1, 1. I can prove that by deleting that word static and running it again. And we see that it prints 1, 1, 1. Yes, sir?
So which one's more easier to keep track of? Making a static variable inside your function or making a global variable?
I would use a global variable if it needs to be shared between multiple functions. Otherwise, I'd make it static. You're right. To do the same thing, you could make everything global, right? Because it kind of means the same thing. A static variable is like a global variable. It's just one that's defined inside a function. So that would be my rule of thumb.
So if you made it a private static, then it'd be like just a regular variable?
You couldn't make it private. The keyword would not work in this context. What happens if you declare a global static variable? Does that even mean anything? I'm expecting to see that pop up a syntax error. But it didn't. What if I try to run it? Huh. Do you see why I'm puzzled over that?
Because it's the same thing as...
It's the same thing. A global variable already has, a lifespan of forever or until the program exits. Odd. Doesn't give you a syntax error, though.
Can you do double long static?
Static has to be the first word.
So static double long.
So you could do static long double D if you needed to. I don't think double long works. Maybe I'm wrong. Static double long D. Okay, prove me wrong. But the data type's supposed to be long double. That's what I've heard it called, rather than double long. But what do you know? It seems to accept it either way. C++ sure is loosey-goosey about applying its syntax in some cases. But does a keyword static have to appear first? I believe so. Watch it prove me wrong again. This language is really loosey-goosey. It doesn't care whether I put. How about if I make it a const? Now, const static would be ridiculous. Why? Because you keep something static so that it will maintain its state and you can keep changing its value, but if you make it const, it won't let you change it. Yeah, all right, that's weird. Anyway, I would use the keyword const in front, and I would use the word static in front if I was going to do that. Const, I'd probably make static the first word, because that's the most weird thing about that variable, is that it's static. I wouldn't wait until the end to note that it was static. I'm going to delete those two examples and come back and put the word static there so it'll work. So static variables are defined and initialized only the first time the function is executed. They're given a default initialization value of 0, just like global variables. So I didn't actually even have to do that. But I like giving initial values, even if I'm just giving 0. To me, it makes the code look nicer, right?
Hey, real quick, can you have two constants in when you call out something?
Like what?
It's like if you just do constant, 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 it doesn't give me an error.
I think it's giving me one now.
What about constant, static, constant?
Oh, constant object must be initialized. Okay, that's my problem. I didn't give it an initializing value. Now the syntax there is going to go away. Well, that's crazy. Does that mean that you can use a static keyword over and over?
Yep.
Alright. Nope, I don't know why it allows that. Why it allows you to repeat the word constant. It doesn't make it better to repeat it multiple times. Alright, my voice is about to give out. We're getting close to the end. Default arguments. A default argument is one that is passed automatically to a parameter. You either declare it in the prototype, or if you don't have a prototype, you put it in the header. So like this. I need a function that I can give a default value. Void add 2, and it's going to take two values, int x and int y. But if they don't specify any values, then int x and y are initialized to be 1, not 0, just to prove that this can work. And so what does this do? It prints out the answer, right? X parentheses x plus y in parentheses error ENDL. So then when I call add 2, I can specify values, but if I don't, it's going to add 1 and 1. So I can do add 2, 10, 10. I can do add 2, 10, in which case it's going to add 1 to 10, right? Because x gets filled in with 10. Oh, semicolon's gone. X gets filled in with 10, but y is not provided with a value, so it defaults to 1. And the last time, we don't give any values for x or y, and so they both default to 1. So it ought to print 20, 11, 2. and that is the case. Now something you can't do is give a default value for the first one and then no default value for the next one. Right? Because how would it know which 110 was supposed to be filling, right? Is it going to fill in that one or is it going to fill in that one? So to prevent that kind of ambiguity, once you start providing default values, the rest of them have to be given default values as well. Now you can define your default values in the header like that, or you can define them in a prototype, but not both. So you could do this: void add to, int x is equal to 1, int y is equal to 1, and then you would remove the default values from here. Now why? Oh, what do you know? Oh, semicolon. Why do you do that? Because your prototypes will be defined in a different context than the function itself, right? This could be in a header file, and this could be in a separate CPP file, or even in a different library altogether. Well, the header is where you have to specify your prototypes. And your prototypes have to be the one that specify the default values in that case. Because otherwise, if this was tucked away in a different CPP file, and we did not have default values in it, then the calling code wouldn't know that it could get away with skipping passing values to it. I don't use default values all that often, honestly.
What if you have a string, like, well, if you were calling if your function, like, asks for the input, for the argument,
Yeah.
how do you, like, so if you had a string and you wanted it to be blank, when you called the function, would you just put quotes?
Yeah, yeah. Like this, void ask me, and it takes a string. You could say, you know, print that string out followed by a question mark, and then we could let them type in something, whatever, right? Just an example. So when we call it, ask me, what is your age, right? But we could just pass in that. Just got to print a question mark. Or if we wanted that option of passing nothing to it, we could have given it a default value and then just not passed in anything.
And then that would be the same if it was an integer?
Right,
Int.
right, right.
So you would say equals 0, right? When you initialize an integer, you just say equals 0, right?
I could, but it's going to be filled in by that CIN no matter what, right?
But when you call it, do you not have to leave you don't have to have an argument?
I don't have an argument here, so I'm letting it accept that default value here. Now, if I'm asking for I probably would return I, you know, and then I would need to make this return an int, and then I could store its result. I get the idea I'm not answering your exact question.
Well, it's just like, I understand that if for a string you wanted to, so when you're calling the function for ask me in the main function,
Yeah,
instead of initializing it in the at the top, you just can put quotes, right?
I could put quotes here.
Yeah, and if it was, say you actually wanted an integer, like you don't want a string, yeah, and then you were gonna CIN the actual integer, how could you?
You better pass in a 0.
Okay, that's.
You either have to pass in a 0 there, or you give a default value here, so you can get away with doing that.
Okay.
Okay. All right. I've talked about references the whole class, so I can skip that section. Overloading functions. We only have one topic left. Let's go ahead and cover it. And then we'll have to hit it again. Overloading functions is when you provide the same function name but give it different parameter lists. And I probably have done this. Like, we're going to write a function called sum that takes one number and returns that number. But I'm going to write another version of sum that takes two numbers and adds them. But I'm going to give it the same name, int x and int y. And it returns x plus y. And I'm going to write another version that takes 3. So it returns x plus y plus z. And then I'm going to write a version that takes doubles. Double sum takes double x, double y, double z. So now I've got 4 versions of the same function. They all have the same name. The compiler will figure out which one I need. So down in main, I can see out, the sum of 1. I could see out adding 2 numbers, see out sum of 2 comma 3. I could see out passing in 3 integers, sum of 4 and 5 and 6. I could see out passing in 3 doubles, 4.1 comma 5.2 comma 6.3. So the advantage to that is I only have to memorize one function name, and then I can use it over and over with different data types. Or with different numbers of parameters. And that can be useful. Otherwise, what would I have to do? I would have to call one of these functions sum2i to show that it's summing 2 ints, and sum3i to show that it's summing 3 ints, and sum3d to show that it's summing 3 doubles. Right? It's cooler, it's nicer, it's easier to understand if I can give it the same function, and the functions can differ their behavior based on what parameters they are, but if they're generally performing the same task, they should have the same name. Make sure it works. Yeah. I hope that makes sense. And we'll hit the idea of overloading again. We haven't had much call for writing functions that accept multiple data types. But if you want to write a function that will accept a double, and another function that will accept an int, right? Like if you're going to divide 2 ints and you want to return the result as an int, but then you're going to write another one that divides 2 doubles and returns the result as a double, you just overload it. Overloading sounds bad, but it's not overloading, and the engines are overloading. No, it's not bad at all. I don't even know really why they called it. What it means is giving the same function with different parameter lists. Now the parameter list can differ by the number of items, or by the type of items, or both. Right? We've seen both of those happen here. Here, these two differed by the types of the parameters, and these two differed by the numbers of the parameters. And it's up to the compiler to figure out which one. And if it can't figure it out, it won't compile. What do I mean by that? What if you have 2 functions with the same parameter list but different return types? Well, it would have no idea which one you wanted, right? If I wrote a version of sum that took 2 ints but then returned a long for some reason, I'm going to undo this because it's a syntax error. And this will be the last thing we cover today. Right? Then when I call sum, it doesn't know which one I want. It doesn't know whether I want that one or that one. So you cannot overload 2 functions giving it the same parameter list but at different return types. They have to be different based on the parameter lists. All right, delete those. Dropbox time. Thank you for letting me keep y'all here a few minutes late. Nobody stood up and walked out on me, which you could very well have needed to do.
Well, we can answer for you if you do.
Nah. If I kept you here an hour late, yeah. All right, so this is lecture P. Alright, I'm gonna slack off, let y'all slack off. I'm not gonna give you a homework assignment that you have to worry about over the break, so. Go ahead and upload that and we are done for the day. I didn't ask. Did anybody get any syntax errors here that they wouldn't? Okay.